interesting question to solve from mechanics. Let's do it one by one. So the first question is asking, uh, determine the x and y components of each force acting on the gusset plate of a bridge truss. Show that the resultant force is zero. So here we go. This is the diagram they have given us, and we have to show this the resultant force of this is zero. So first of all, I have to draw the diagram again. So in this case, I'm going to take this one, take this sketchbook. Okay, here we go. So this is our sketchbook, and I'm going to draw this diagram again, like this, and one component right here, one component right here, and this is given F1 is equal to 8 kilonewton acting on this direction, and they have given the opposite and hypotenuse right here. It's going to be 4 3 5 4 3 5, and F2 is F2 is equal to 6 kilonewton acting on this direction, and they have given this is going to be 4 5 and 3. So this is what they have given, and the other one is the bottom part is F3 is equal to 4 kilonewton acting on this direction, and F4 is equal to 5 kilonewton acting on this direction. F4 is equal to 6 kilonewton acting on this direction. So this is what we have got right here. Now I am not satisfied with this diagram, therefore I'm going to draw this again. So because if you see this one, like F3 and F4 going in the same direction, and F8 is coming downside, but it's as drawn in the top side, so it's to make everything complicating. So I'm going to draw this diagram again. So since this is this case, I'm drawing this one like this, and I'm gonna just combine, like if something is horizontal or vertical, we can just directly add it, because it doesn't combine with any angle or anything, so we can just directly add it. So this is, in this case, this both forces are facing in the same direction, so I can simply add it without anything complicating anything. So like, let's say F3 plus F4 is equal to 6 kilonewton plus 4 kilonewton, 10 kilonewton in this direction. And since this one is coming downward, so I have to this is come downward from the uh, second quadrant. So if it's coming from the second quadrant, I can throw this in the fourth quadrant because it's facing toward that. So I can throw this one in the fourth quadrant, and F1 is equal to 8 kilonewton, and they have given the hypotenuse and opposite adjacent, it's going to be the same because it doesn't change, because the slope of the tangent slope is going to remain the same, so nothing will change. Therefore this is going to be my diagram for that one, and I'm going to top part is going to be remain the same. F2 is equal to 6 kilonewton, and I'm going to just draw this, and it's going to be 4 3 5. So this is my diagram, this is my rearranged diagram, and now we are good to go. Now in this case, if you have something like this, it's better to we separate the x and y components separately and then add it together. That will make life easier. So let's see. I am putting x components, and here y components. I'm just gonna draw a table right here. So let's do for table for each and everything. So if I look at F1, f1 is facing downward, but the opposite is, so do you have to know what is opposite and adjacent first. So if you see something in y axis, like this is y axis, that means that is opposite. And if you see something in x axis, that is adjacent. So that's how we calculate, that's how we say it's opposite or adjacent, right? And in this case, F1 is 8 kilonewton, and to find the x component of this, we know, like, if it's 30 degree between them, we just say 8 cos 30. But in this case, they haven't given the degree, but they have given the sides here, this this slope right here. So from this I can find it, because cos theta is what, adjacent over hypotenuse. So I can use this as 4 as adjacent, because it's in the x direction. So I can use this 4 as adjacent and 5 as hypotenuse. Therefore it's going to be 8 times 4 over 5. That's my x component for uh, f1. Since this is cos and this is in the fourth quadrant, um, this is going to be positive, because cos is positive in the fourth quadrant. And y value, if you take the y value, it's going to be 8 times, opposite is going to be 3, so 3 over 5. Don't forget, guys, this is going to be negative. Why? Because if you see in the fourth quadrant, x value is positive but y value is negative. The opposite is y value, so it's negative, so therefore it makes everything negative. So we have to be careful about that. So this is negative. And 8 times 4, 8 times 4 is 32, 32 divided by 5 is 6.4, and here it's 8 times 3 is going to be 24, 25 divided by 5 is going to be minus 4.8. So this is the case. And then we have to find the f2. So if I find the x value for the f2, it's going to be 6 times uh, 6 cos theta. So cos theta is going to be what, adjacent over hypotenuse. Adjacent is 3 over 5, so 6 times 3 over 5. And this is going to be also positive because it's in the first quarter. First quarter cos is positive, therefore 24 over 5 is going to be 4.8. Or wait. So 18, 18 over 5 is going to be 3.6. So this is 3.6, and uh, 3.6, and I have to find the y value for this. In this case, y value is going to be 6 times sine theta. Sine theta is going to be opposite over adjacent, opposite over hypotenuse. Opposite is going to be 4, 4 over 5. So 6 times 4 over 5 is going to be 4.8. In this case, it's positive because it's in the first quadrant, right? And the last one is f3 plus f4. f3 plus f4. So these force we added already together is 10 kilonewton, and it's facing opposite to the x-axis. Like if it's this x-axis, this x is positive, this side x is positive, and this is negative. Therefore, we have to put this one negative. So it's f3 plus f4 is going to be minus 10, negative minus negative 10 kilonewton, and this is the 0 points. Okay. Now from this one, now we are going to add everything together and see what happens right here. So if I add all the x components, 6.4 plus 3.6 is 10, and here minus 10 is going to be 0, and here is y components we have found, negative 4.8 plus 4.8 is 0. So both are 0 0, therefore we know fx is 0, fx is 0, fy is 0. So we know the equation for the fr is equal to root of fx square plus fy square, fy square. So since this case both are 0, 0 square plus 0 square is going to be 0. Therefore answer is 0. The resultant force is 0. So the question is asking, determine the x and y components of each force acting on the cassette plate of the bridge truss. So that resultant force is 0. So we have shown that resultant force is 0. So that's the answer for this question. Let's move to the next question. Next question is, I'm going to take the 2.78. This is the question. Uh, the two forces F1 and F2 A facing at A and have a resultant force of Fr is equal to minus 100 kLb. Determine the magnitude and coordinate direction angles of F2. So we have to find the magnitude and coordinate direction angles of F2. So in order to do that, first of all, let's see what I can do with this. So we know all the values of F1. So from this, I have to derive the F2. Let's see what I can do. First of all, I'm going to list all the F1 right here. So if I see F1 is 60 lb already given, so I'm going to put the 60 right here, and in the bracket, I have to find the ijk components. So if I first of all, if I want to find the ijk components, I have to let's find the I first. So if you see, this is downward. So this is, if this is downward, and if I want to bring it to the x-axis, I have to first multiply this one by negative cos 50 to make it to the x components. So it's going to be negative cos 50, negative cos 50, and if I bring it to the x-axis, still it's not x-axis, so it's 30 degree away from this. So to make it to the 30 degree, I have to multiply this one by again negative cos 30 degree, and then this is the I component, and to find the j component, it's still the same sign, but this time it's going to be positive because y is positive in this direction. Therefore uh, here I multiply this one by negative because x is negative in this direction. Because if you see the graph, if they give x, y, z, we have to consider that side as positive. So in this case, they have given x in this side, and we have to find the other side. So that's why I put negative cos 50 cos 30 I, and on the other side, it's y is positive. Therefore, we have to put cos 50 positive, cos 50 positive, and it's since we have reached the x-axis, but we have to reach y, so I have to multiply by sine 30, sine 30, and that's gonna be my j. And to find the c component is like directly downward. So if it's upward, it's positive, but since in this case it's facing downward, so I have to extend it to the downward direction. So therefore I have to multiply the c component by negative sine 50. So negative sine 50. So this is my components right here. This is going to be negative sine 50k. So since we have this one right here, what I'm going to do is I'm going to simply multiply everything and put the values right here. Let's use the Google calculator to do that right here. Okay, so make sure guys, the calculator should be in degree, not in radians. If you put these values in radians, you will get completely different answer. So you shouldn't do that. Therefore make sure this is in degree, and 60 times negative cos 50 times cos 30 is equal to negative 43.66. Let's write that one down. So negative 43.66 I plus, let's calculate the next value, 60 times cos 50 sine 30, cos 50 sine 30 is going to give me 54 point. Let me see that again. Okay, let's calculate. Okay, this is 54.37. Let me put this 37J, and if I calculate this minus sine 50K minus wait, minus minus um, sine 50 times 60 is equal to wait, we are doing something wrong. Let's see. 60 times minus sine 50 negative 45 negative 45.96. Let me double check this values because we have to be careful about this. First of all, minus cos 50 times cos 30 is equal to negative 0.7277, then multiply by 60, I get 43 point, that's right. And the second, let's move to the second one. Cos 50 times sine 30 is equal to 0.9, and I multiply by 60. Okay, that's right. And I multiply for the last one, I find the minus sine 50, then multiply by 60. No, first of all let's calculate minus sine 50, and this is this value, and multiply by 60 is going to be minus 45.96. Okay, we are we are we are right. And now what I'm going to do is I'm going to find the f2 components. So f2 components, we don't know any value, so what I'm going to do is I'm going to just put the values right here, like f2 in for the I I'm going to put f2x I, and for y j component I'm going to put f2y j, and for the z component I'm going to put plus f2z k, f2z k. So as we already know, like resultant forces are going to be equal to f1 plus f2, because these are the two angles that's making the forces resultant force. So if I add these both together, that should give me the resultant force. So fr is going to be equal to f1 plus f2, and resultant force is already given, it's minus 100k lb. So minus 100k lb, I have to put it right here, which is going to give me, I'm going to add I and j k components together. Like for I value, I can simply add it together. So it's going to be f2xi minus 43.66 I, and f2y plus 54.37J, and for f2c I had to do subtract f2c k minus 45.96k 45.96k, and this is gonna be the equation. And since if we take the all of the variables alone, like because if you look at it, if you look at this diagram, the I component doesn't bring the like uh, X component doesn't bring the resultant. Y component doesn't, because the resultant is acting on Z direction. So therefore we can only equalize this one to f2zk minus 45.9, because others are going to be 0. So I can, let's see, so f2x I minus 43.66 I is equal to 0, because um, because in the I-axis, like I-axis resultant force is not going to be in the I-axis, it's not going to be in the J-axis, it's going to be in the Z-axis, because uh, that's why imagination is simple. Because like if you like imagine if you're pulling from the both direction, F2 and F1, so you are pulling down, right? So it means you are pulling it down, not in the X or Y axis. So it's going to be in the Z direction. Therefore whatever the value in the X or Y component should be 0. That's why I got it right here. This is equal to 0, and f2y minus 54.37 is equal to 0, and then f2z minus 45.96 is going to be equal to minus 100k lb, 100k lb. So we have multiply this one by this lb, and k is a constant. Don't think it's a kilogram, it's just a constant. Therefore we don't have to convert into kilo and then subtract, we don't have to do that. So since in this case it's going to be f2x is going to be equal to 43.66 43.66 lb. F2y is equal to 54.37 lb, and f2c is going to be 45.96 minus 100 klb. So we have to find the value for that one. So in order to do that, I'm going to use a calculator. Let's see. 45.96 minus 100 is going to give me 54.04. So this is 54.04 lb. So these are the F2 values. Now what I can do is uh, we can't write LB because this is still IJK components. We didn't find the magnitude yet, so we have to be careful about that. This is IJK K components, I components, J components, K components. Now since we have these both right here, now what I can do is I can simply add them both, because FR is equal to F1 plus F2. So let's see. So if I add them both together, what I'm gonna get? Oh, actually we don't have to add it, because the question is not the resultant force, right? The question is asking magnitude of The question is asking determine the magnitude and coordinate of angle of F2. So the question is not resultant first. So we have to be careful about this. Yeah, question is whatever they are asking, we have to give. So F2 we have found the I and J K components. Now it's very easy to find the resultant ones because the resultant one is going to be what? F2 is going to be equal to square root of I have to just square it in the bracket, that's it, like 443.66 square plus 54.37 square um, plus, so since all of them are plus, but this would be minus because this is my okay minus, but if I square it, it's going to be a plus, so sign is not much important. For 54.004 square, so let's see what happens. Okay, so 43.66 square. So in order to square, I had to change. No, we don't have to change. Let's see. How can I square this? Okay, square. Okay, 1906. Okay, I'm gonna simply add and square so make everything easier. 54.37 square plus 50.050. I'm just gonna leave it as positive because whatever the negative value you square, you're gonna get a positive value, the same number. So I'm gonna keep it to positive 54.04 square, so equal to this one. So it's gonna be square root of 77826. So if I square root this one, 778.2.6, if I square root this one, I will get the answer 88.21. So this is the force of the F2. This is the answer for the F2, magnitude of F2. But we are not done yet. So they are saying determine the magnitude and coordinate direction angles of F2. So we have found the magnitude, but we haven't found the angles yet. So this is magnitude. So if you see, F2 has three different angles, I, J, K components, right? So each gonna make different angles. So if we say it's let's say it's alpha, beta, gamma. So we have to say alpha, beta, gamma because if we have three components, that's how we name it. So alpha is going to be what? Alpha is going to be 40, like I components is going to be my alpha. So 43 point. We had to, so like what we have to do is we have to find the cos inverse, because cos alpha is going to be equal to let's see, let's write this one first. Cos alpha is going to be equal to 43.66 over 8821. So in order to find the alpha is the question, alpha is the angle. So in order to find the alpha, I have to cos inverse this one. So cos inverse 43.66 over 88.21. So let's find this one. So this is cos, and since we don't have inverse right here, I'm going to use a different calculator. Here we go. Okay, in this calculator we have everything, I guess. Also, yeah, we have everything. So make sure this is in degree. Um, and what else? Now we have to find the cos inverse. Cos inverse. Oh, so for this calculator works like this. First we have to find the value and then cos inverse. So 43.66 divided by 88.21 is equal to this. And if I cos inverse this one, oh god, this is not in degree, this is radians. So let's see. 43.66 88.21 is equal to this. Cos inverse, yeah, this should be in radians, guys, be careful, this should be in radians. 60.33 and alpha beta. So to find the beta, let's plug it directly instead of doing step. I'm just gonna plug it directly and put the values right here. So this is 54.37. So let's see. So cos inverse. Oh, so first of all, I find the values right. So it's going to be f2 by f2 y value is going to be my beta. So 54.37 divided by 88.21. 54.37 divided by 88.21 is equal to this number. And if I cos inverse this one, 51.95 degree. So this is my beta. Now I have to find the gamma. Gamma is going to be z direction. C's direction is minus 54.04. Negative 54.04 divided by 88.21 cos inverse is 127.8 degree. So this is my final answer. So this is the final answer for the second question, and let's move to the third question. Third question. Third question, they have given if Fp is equal to 700 Newton and Fc is equal to 560 Newton, determine the magnitude and coordinate direction of angle resultant force acting on blackboard. So let's see this. So Fp mean if it's going from AB, so we can say it's FAB, and Fc is going from AC, we can say this FAC. So I'm going to write that first. FAB is equal to 700 Newton and FAC is equal to 560 Newton. 560 Newton, and in this case, to find the like magnitude, the resultant of, so FP actually, to find the FAB, first I have to find the unit vector. So unit vector is going to be first, to find the unit vector I have to find the B coordinates and C coordinates. So let's find the B coordinates. B coordinates are going to be what? If I look at it, it's going to be from x is going to be equal to 2, x is equal to 2 for b1, b1 x is equal to 2, y is equal to negative 3, c is 0 because it's in the bottom level, so c is 0, and for c is for c x is gonna be equal to x is gonna be equal to 3, positive 3, and uh, so we are putting the value in the respect of the way the diagram is. So if they put the x value here, and if you see some value opposite side of this, it's going to be negative. So if they give y, if they put the y mean, that side is positive. So wherever they put x, y, z, that side is positive. We have to consider. So that's how I'm writing this. So c is 3, and y is going to be 2, and x is going to be 3, x is 3, y is 2, and c, this is in the bottom level, therefore c is 0. So this one we got the coordinates for this one. And for the a coordinate, for the a coordinate, it's in the axis, origin, it's in the origin but a little bit higher, therefore x and y are 0. So since this has a little bit height here, we have to measure the height. Height is going to be 6 meter, so we have to put 6 as the c value. So this is my a coordinate. Now first of all I had to find UAB, unit vector AB. So in order to do that, I have to first subtract, if it's AB. So if you see something like AB, what you have to do is you subtract the uh, B from A. Subtract the B from A. So it's going to be what? 0 minus 2, 0 minus 2, and then let's see, 0 minus 2 first, 0, okay, 0 minus 2, then 0 minus 3, so it's going to be positive 3. So 0 minus 2 I plus 0 minus 3 j plus 0k over we have to square root this one. Oh, it's not 0k because here it's 6 minus 0, it's gonna be 6k. So we have to be careful about it. So in the bottom I have to square everything and add it. That's going to be the magnitude. So if I deduct this one by this magnitude, it's going to be the UAB. So it's going to be minus 2 square plus minus 3 square plus 6 square. So since we have this one I right here, it's going to be minus 2i plus 3j plus 6k over minus 2 square is going to be 4. 4 plus 9 is going to be 13. 30 plus 6 square is equal to 36. 36 means 49. So total square is 49. 49 minus 2i plus 3j over root 49 is equal to 7. So I can just directly write 7 right here. So let's see. So I have to simply divide everything by 7 separately, so I can find each value. It's like negative 2i over 7 plus 3j over 7 plus 6k over 7. So this is my UAB, and my UAC. Now I have to find the UAC. So I have to subtract A from C. So if I do, I mean, I have to subtract C from A. C from A. So C from A, and then square root the whole values. Right. Let's see. 3 0 minus 3 and I plus 0 minus 2 j k no, I j 0 minus 2 j plus 6 minus 0 k, so it's 6k over minus 3 square plus minus 2 square plus 6 square. So which is going to give me what? Minus 3, like minus 3 square 9 plus 4 plus 6 square is 36. So 13 plus 36 is going to be 49. 49 is going to be 7. Square root of 49 is 7. So minus 3i plus minus 2j plus 6k over 7. So therefore I can simply divide each factor by its term, so it's going to be minus 3i over 7 plus minus 2j over 7 and plus 6k over 7. So this is my UAC. Now to find the, now we have to, the question is, let's see, the question is asking magnitude coordinate resultant force acting in the flag force. So I had to find the FAB and FAC. FAB, FAB simply it's gonna be FB. FB the it's because it's acting on that direction. So to fact FB is acting on which direction? A, from A to B. So I had to use FB for this one. FB times UAB is going to be give me FAB. So UAB we found it already. So FAB is what? FB is what? FB is 700 Newton. 700 Newton multiplied by this whole thing, minus 2 over 7, minus 2 over 7 plus 3j over 7 plus 6k over 7, 6k over 7. So if I simply multiply this one, 7 7 cancel, so 100, it's going to be 100 times negative 2 is negative 200i, negative 200i plus 300j plus 600k. So this is my FAB, and now I have to find FAC. FAC, to find the FAC, same thing, 700, FAC is not 700, it's 560, 560 because FC is 560. So I had to FC times UAC, FC times UAC. So this is going to be 560 times, 560 times whatever the value we find here. So minus 3i plus 2j over 7 minus 2 plus 2 minus 2j over 7 plus 6k over 7. So we have to multiply. So let's see if 560 can divide by, so 8 times 7 is 56. So 8 times 7 is 56. So since this one is 560, so it's going to be 80. 7 times 80. So it's going to be 80. So 80 times minus 3 is going to be minus 240i, and 80 times minus 2 is going to be minus 160j. 80 times 6 is going to be 480k. So now we have find the FAC value. So to find the FR, I have to simply add both together. So let's see, the question is asking find the direction axle of the resultant force acting on the plane. So the question is angles, but anyway we have to find the resultant force, because to find the angles we need the resultant force. So FR is going to be FAB plus FAC. FAC, and FAB is here, minus 200 plus, let's add it together. I'm just gonna add it by my mind, because if I we don't have to write everything, right? So minus 200i plus minus 240, it's going to be 400 and minus 440 40i, and minus 160 plus 300. So minus 160 plus 300 is going to be my 140j, and 480 plus 60 is going to be 540k. So 540k, this is going to be my FAB plus FAC. Now since we have got this one right here, to find the real FR, I had to magnitude of FR, I had to square root it, and square root it. So FR is going to be equal to square root of minus 440 square plus 140 square plus 540 square. So if I do this one, let's see what we get right here. Let's see. So I'm using the Google calculator here. So minus 440 minus 440 square plus plus 140 square 140 square plus 540 square plus 540 square. So let's see the value. It's 117600. So the value is giving 117600. Let's put the value down here. It's square root of 117600. Now I square with this number. Let's see what happened. 117600 117600. If I put it, it's going to be 342.9 342.9 what Newton. So this is my resultant force, but we are not done yet. Now we have to find alpha beta gamma. So in order to find the alpha beta gamma, so let's see, I am going to do this part here. We don't have enough space here. So alpha beta gamma. To find the alpha is going to be I component. So alpha is I component, so I have to cos inverse, like cos alpha is going to be equal to um, minus 440 is my I component right here, resultant force I component. So minus 440 over 342 340.9 Newton. So since this we have this one right here, to find the real alpha I have to divide it by the resultant force, and then cos inverse it. So alpha is going to be, because cos alpha is going to be this over this, so alpha is going to be cos inverse this over this. Cos inverse minus 440 over 342.9. Let's see what we get right here. So if I have this calculator, okay, minus 4, where's that question? Okay, minus 440 minus 440 divided by 342.9. Cos inverse. Wait a minute, something wrong, because the value is above 1. Did I made any mistake right here? Let's see. Let's see. I'm gonna find the FR value and make sure if we got the right FR value. Okay, so the FR value is minus 440. Negative okay, 440 square 440 square plus 140 square 140 square plus 540 square 540 square. So it's 291600. Okay, we got this number wrong. That's the problem. So 291600. 291600. Okay. So now if I square root this one, let's see what happens. 291,600 square root 540. So the answer is 540 Newton. So the resultant force is 540 Newton. So that's the mistake we made here. So that's what we have to careful. We have to be careful. 540 Newton. So now to find the cos alpha, alpha, right? Alpha is cos inverse minus 440. Now instead of 342, I had to divide it by 540. Now I will get the right answer. 540. So which is gonna give me what? Let's see. So since we have this one right here, I'm gonna divide this by this calculator. Okay, 504 minus 4 negative 440, 440 divided by 540 is equal to this value, and if I cos inverse this, 144.5 degree, 144.6 degree. This is my alpha. So now I have to find beta. Beta is going to be equal to j component. J component is 140, and it's going to be divided by this, and that's going to be cos alpha, so cos beta, and beta is going to be cos inverse of that number. So cos inverse 140 over 540. So it's going to be equal to, let's see, 140 divided by 540 is equal to this, and if I cos inverse this one, 74.97 degree, 74.97 degree. So this is my beta. Now I have to find the gamma. Gamma is going to be the C component. C component is equal to 540. So okay, C component is 540. Yeah, C component is 540. So 540 divided by 540. Oh, that's going to be interesting. Cos inverse 540 divided by 540 is going to be what? Zero degree. I can't believe this. I can't believe this. 480 plus 60, 540. C component is 0 degree. So I think this, okay. So the resultant force makes C component equilibrium. So this is our final answer. So alpha is 144.6 degree, and beta is 74.97 degree, and gamma is 0 degree. So I hope you guys enjoy this video. See you next time.